So we have one last log identity. And this is one of the more important ones. Well, they're all important, but this one's even more important, change of base formula. So what is the log change of base? It says that if I have log base b of m, I can change the base to anything I want. So for example, log base c. But if I do that, how do I change from log base b to log base c? And what I'll do is take log base c of m and divide that by log base c of the base itself. So what it looks like it's happening is I pick whatever base I want, doesn't matter what it is, then the input goes to the numerator, the base itself goes to the denominator. Okay, so this is what it looks like. Now remember, the base is usually a constant, right? That's what this is, a base is a constant. So another way of sort of thinking about this, notice, is that maybe I'll share. So this is equivalent to, remember, if I divide by this, is the same as log. It's easier to think about, don't switch it to this reality. But what I want to is bring a point here that all of a sudden, all logs are connected to each other. How? They're connected because if this is a constant, this is just a number, it looks like it's either a vertical stretch or a vertical compression. So all logs are connected via just stretching them or compressing them. Okay, just keep that in mind. That's how they're all connected, which must means that exponents must suffer exactly the same fate, since logs and exponents are tied together. All right, so here's a proof of this. I'm going to first let b of x equals m. Okay, and as soon as I say that, because I can, in log form, this would be log base b of, now the m is equal to the x. Okay, so we have these two expressions. I'm going to start first again with this one. So have b of x equals m. Now I'm going to take log c of both sides. So we have a log c of b to the x power, and this side is log c of m. Fantastic. Now what? Well, I'm going to use the power rule here to bring that x down. So that's using the power rule. And now I'm going to divide both sides by log base c of b. So when I do that, I have the following. And you can see that I have now part of the formula. On this I have x, but then I recognize what is x? Well, x is just log base b of m, and there is the proof. So now replacing x with what it is in log form, I have log base b of m is equal to log base c of m divided by log base c of b. Okay. So how does this work in practice? For example, use a calculator to find log base 4 of 22. So now some modern calculators allow you to just find the log of any base, but the old ones don't. And some of them just, because there usually is no need to have a button that does this because of this formula. So if I wanted to find an approximation of this, I'm either going to choose log base 10 or natural log. So which one? Log base 10 or natural log? I'm just going to go natural log. So if I choose natural log, then divide by natural log, and then what to input? This, which was the log of base 4 of 22, goes in the numerator, base goes in the denominator. So if I click natural log of 22, divide the, close it, divide that by natural log of 4, close it, I get approximately 2.22976. Okay. Now, does it matter which log you use? The answer, no. No, because I just said that the logs are connected. How they connected? By stretching or compressing. So if I decided to do instead log base 10, for example, then what's happening is that, remember, log base, natural log of 4 is some number, log base 10 is a different number. So this is either going to stretch or compress differently because I'm using a different base. So this is the final thing that connects them, is that I'm stretching or compressing enough to match the other base. So if I did that, what do I get? It's going to be the same number, but let's just check it out. Not that one. Log of 22, close it, divide by log of 4, close it, and you can see that it's exactly the same number. 2.229716. Okay, so just a quick little maneuver here. Why does a single logarithmic? So now I notice the bases are different. So if I'm going to try and write these as a single log, I need to choose a log that they're both a common log, or not the common log, but a log, same base. So let's decide, I decide to change this to log base 3. So if I decide to do that, then what I have here is log base 3 of 4 and log base 3 of 9. Okay, now I recognize for a second that just to clean this up a little bit, 9 is 3 squared. So what I have here really is, what is log base 3 of 9? The answer is 2. And again, if you recall, a little aside here, what I'm doing is log 3 of 9 is really log 3 of 3 squared. And these two being inverses of each other, I get 2. Then I can rewrite this again as log base 3 of 6 plus 1/2 log base 3 of 4. Rewrite one more time. It's 3 of 6 and raise this to use the power rule. Bring this to the top. Remember, 4 raised to the half power is the same thing as the square root. So what is the square root of 4? The square root of 4 is a 2. So I got log base 3 of 2. And now using the power rule, I got log base 3 of 12. And there I have what is a single logarithm. Let's do one more here. Write as a single logarithm, this last one. So again, I have a choice. This is log base 10. This is 100. Tell you what, I'm going to go with changing to log base 10. So I'm going to change the log base 100 to log base 10 because I'm starting to see a benefit here. So it's log base 10 and 100, which goes right here, is 10 squared. You see where I'm going with this? Same thing as I have with the other one. I go log base 8 here. So now these are inverse functions. So I get again a half, again, just like I did for the other question. And you see that it's going to be the same situation as before. I had log base 10. Want to bring this to the top. I had the square root thing going. That's what's going to happen here. I'm going to just do it in one shot. So log 4.5 that's log base 8. And so here I'm going to get 2. And now I have the quotient rule situation. I'm subtracting two logs, the bases are the same, so what I have is log 2 divided by 8, reduce that down, and what I have now is log of 1/4. And there I have it. I've written now as a single log. I've written.